In 2009, Stacy Castor was charged with the murder of her second husband, David Castor, attempted murder of her daughter, and forging a suicide note. But that leads to the question, how did she get caught, how did she do it, and why did she do it? Answer to the first question is mass spectroscopy. And we have asked our leader, the field leader, expert in the field, Senior Dr. Ali Ahmed, aspiring doctor in the field.
Okay, so with mass spec, we get samples and then we vaporize them. Then these samples, after they're vaporized, we put them in an ionization chamber where they are bombarded with electrons. The way we bombard them is there's a heated metal coil that gives off electrons, and these electrons are attracted to a trap that's positively charged. So on the way when they're attracted to the metal trap, this trap, electron trap, they knock off some electrons from the sample itself, and then they form 1+ ions. Next, these ions pass through a velocity selector, which determines if they are able to pass through a slit and then go on to the next bit, which is the deflection bit. Ions are, the usual 1+ ions are deflected depending on their mass to charge ratio. The lighter the ion is, the more it is deflected, and the heavier it is, the less it's deflected. Once these ions get deflected, they move on to an ion detector. In this ion detector, there's a metal box that has electrons. These electrons, when the ions get to them, their charge gets neutralized by some of these electrons. And then when the electrons move out of that metal box, they leave a space. That space is filled in with the other electrons in that metal box, and they shuffle in, and that flow of electrons is recorded as an electric current. And this flow of electrons is then amplified to give us the graphs that we see of like the mass spec graphs, and they allow us to determine how much of that ion is present in that sample. So it gives us abundance and its charge. So here I have an example of a mass spec graph that shows me the composition of methyl hexanoate. Here I can see that there's an M+ peak at 130, and M+ just basically means it is the compound without any fragmentation done to it. So it's basically the compound itself before any separation. And here I could see that there's a base peak of 74, which is base peak basically meaning it's the peak which had the most abundance. So that's the peak basically the compound, like the part of the compound that we saw most of in that sample. This allows us to work out the different isotopes of an atom and work out their different abundances and basically work out the amount.
So I have one apple and I have two apples. So suppose that this apple is 50 grams and this apple is 25 grams. They're both apples, both taste the same probably. And so if I ate them, I'd be just as happy. And they all have the same properties, just different masses. This is the same with elements. If I have one atom of say hydrogen with its one proton and one electron risen around it, and then I can also have some hydrogen with one proton, one neutron and its electron risen around it, which is called deuterium. These both have the same properties when they wanted to react. So once you react it with some oxygen, I would still get water. So this means that they are isotopes of each other. Atoms with different masses of the same element that have the same number of protons but different number of neutrons. So imagine I have many of each of these apples, and then out of these many I have 66% of the 50 gram apple, and then 34% of the 25 gram apple. That would mean, if I crunch the numbers, I would get out an average mass of 41.5 grams. This is the same for elements. If I get their relative abundances, which is how many in a sample is that element and of that mass, then I get what is called the relative atomic mass, which is the weighted mean mass of atoms of an element compared to 1/12 the mass of carbon-12.
So now that we know the answer to our first question of how did she get caught, we can answer the second question of how did she do it. she used a hazardous substance found out in our MR spec, which is commonly found in antifreeze. The chemical in question leads to multi-organ failure within 24 to 36 hours after consumption. It is believed that Stacy Castor fed it, but we don't know really how, it wasn't discovered, to her husband, David Castor. This led to his death and, well, her investigation under the suspicious circumstances. We spoke to Dr. Senior, aspiring Dr. Ahmed, our trusted guide and expert in the field, to expand upon this information.
So after they did a mass spec of traces of antifreeze in the house, they found out that antifreeze contained the compound ethylene glycol, which had an M plus peak of 62 and a base peak of 31. That base peak of 31 being CH2OH plus. And then this is different to the mass spec, which was methyl hexanoate, which had the M plus peak of 130 and a base peak of 74. So they concluded that Stacy Castor attempted to make her husband David ingest antifreeze in some way or another.
We can finally look at her motivation behind doing it. It was revealed in court that her motivation was, in fact, the life insurance. During her whole court statement, she used the words anti-free instead of antifreeze, showing that she did not care for the slightest about her actions, and that her whole court statement was, in fact, computer generated. However, Castors Case is not the only one. Hundreds of cases include using mass spec to convict people, and I've got a few examples here, such as the murder of Graham Backhouse in 1984, where explosive residue was detected, or Amanda Knott's is his case, where, despite the lack of DNA evidence, mass spec was used to identify her as the perpetrator in a murder. This leads to saying that, like, perhaps DNA evidence is less reliable than MR. There are also other uses apart from murders and other explosive junk. There are other uses for mass spec testing, such as in sports where you can test for doping. And that leads us on to our next segment.
Mass spec has improved drug testing in sport, as it has allowed for higher precision, faster testing times, testing of more types of drugs and other hormones and compounds like that, and testing of a wide variety of items such as blood, urine and hair.
Mass spectroscopy, as a growing technology, may prove to be more reliable than DNA in the future. However, its uses are not only within your typical murder analysis or your doping. There are many other uses, such as rock analysis, which might sound boring, but it could lead to the search for life on places like Mars or Bennu or Europa or all your different planets, which leads to all different types of physics, from your chemistry to your biology or your physics, or I don't care if you're interested in some other stuff, but we don't care about them. With that, I think we can conclude this video.